Here we want to talk about the distance between two skew lines. So what are skew lines? They're lines that are non-intersecting, non-parallel. So if I look at these two pens, these would be two skew lines. Kind of difficult to see here in this world. But how do we find the distance between two skew lines? Let's take a look at another image. This is going to be helpful. So I have lines that exist in different planes. These lines are not in the same plane. If they're intersecting lines, they live in a single plane. If they're parallel lines, they live in a single plane. These lines live in two different planes. Now, how do I find the distance between them? So you'll notice there is some sort of a line segment that connects these two that is perpendicular to both. So think about that for a second. What can we find that will be perpendicular to both lines? What tool do we have that enables us to find something perpendicular to two other concepts? Let's keep that in mind as we are doing this. So we have two lines here. Line 1, x is 3 plus t, y is 5 minus 4t, z is negative 1 plus 2t. So we'll talk about a point P on line 1. 3, 5, negative 1 would be a good point on line 1. And we'll talk about the direction vector on line 1. What is my direction vector on line 1? 1, negative 4, 2. On line 2, let's call the point Q, which will be 1, negative 3, 2. We'll call this direction vector 1. We'll call this direction vector 2. Direction vector 2, 2, 1, negative 1. So how are we going to find the distance between these two skew lines? So I'd like to find something orthogonal to both. So looking at our previous picture, what is orthogonal to both of the direction vectors? Let's call that n, that is a normal vector to both of the planes that these vectors sit in. And how am I going to find a vector orthogonal to both of those planes or a vector orthogonal to both of those vectors? And the answer is going to be for us to find a cross product. So the normal vector I'm going to need to find here is going to be the cross product of dv1 and dv2. So how do we do that cross product? You go ijk across the top. And we know it goes plus minus plus across the top. dv1, 1, negative 4, 2. dv2, 2, 1, negative 1. So let's go ahead and find that normal vector. What is that going to give me? Plus I. In i's direction, what do we have? Cross out the row that I is in and the column that I is in, which gives me negative 4, 2, 1, negative 1. Minus j, same idea. Cross out the row that j is in and the column that j is in. It gives me 1, 2, 2, negative 1. Plus k, cross out the row that k is in and the column that k is in. 1, negative 4, 2, 1. So what will that give us? What do we get for n? Negative 4 times negative 1 is 4 minus 2. So I plus I times 4 minus 2 times minus j times negative 1 minus 4 plus k times 1 minus negative 8. So my normal vector to both is going to be 2i -1 minus 4 is -5, but with the minus sign, I make that plus 5j. And then 1 minus -8 plus 9k. So my normal vector n is going to be what? Is going to be 2, 5, 9. So that will be orthogonal to both lines. So let's go back again and look at that picture. So I've constructed this vector. Now, I'm going to project something onto that. What am I going to project onto that? I've got to choose a point on each line and construct that vector, and then project that vector onto this vector that's orthogonal to both. So I need a point on plane number 1. I need a point on plane number 2, a point on skew line number 1, a point on skew line number 2. Construct that vector and then project that vector onto the normal vector that we just constructed, the normal vector 2, 5, 9. So these are the points we found before from setting the parameters equal to 0. Point P was on the first skew line. Point Q was on the second skew line. So I want to construct vector PQ or QP. Doesn't matter which direction you go. From 3 to 1 is down 2. From 5 to -3 is down 8. And from -1 to 2 is up 3. So that is PQ connecting 2 points on the 2 skew lines together to construct a new vector, vector PQ, -2, -8, 3. Now, the normal vector that we constructed that was orthogonal to both direction vectors is 2, 5, 9. So what do I need to do? Again, I have these 2 skew lines. Picking points on each, maybe the tip of this pen and the tip of this pen, is going to construct a new vector, and then we're going to project that onto the one that is normal to both, that is orthogonal to both. That's how this is going to work. So the projection of PQ onto N is going to be our distance. To remind ourselves, if P is up here, imagine this is a point P, and this is a point Q, construct that vector from P to Q, and then project it onto the normal vector. That will give us the distance between the two. So how do we do the projection of PQ onto N? Projection of PQ onto N is PQ dot N over N dot N times N, which is what is PQ dot N? -2 times 2 is -4. -8 times 5 is -40. 3 times 9 is plus 27. How about N dot N? 2 times 2 is 4. Plus 5 times 5 is 25. Plus 9 times 9 is 81 times N, which gives me what? Adding those things together, I get -17 over 110 times N. So the distance between the 2 skew lines is going to be the magnitude of that projection. The distance is going to be the magnitude of the projection of PQ onto N, which will be the absolute value of -17 over 110 times the magnitude of N, which is 17 over 110 times, again, same thing we did before, but magnitude of N, square root 2 times 2 is 4, plus 25, plus 81, which is 17 over 110 times the square root of 110, or if you prefer, 17 divided by the square root of 110, which is approximately how much? 17 divided by the square root of 110 is about 1.62 units.